Hey guys, we're going to talk today about basic derivative rules. You can see here three things we're going to talk about. We're going to talk about the constant multiplier. We're going to talk about a polynomial, and we're going to talk about derivatives of sines and cosines. All right. So as we do this, first of all, what I want you to think about is what is a derivative? All right. So let's say we have f of x equals c, and c is any constant. So c is any constant. Now keep in mind what this really is. This is the graph of y equals c, which we know to be a, look at all these parenthetical statements. We know that this is a horizontal line. And we've learned that the derivative, we know that the derivative is the slope. Okay, so if the derivative is the slope, well, what's the slope of this line? It's horizontal, so that derivative has to equal 0. Okay, that derivative has to equal 0. So I think I put things out of order here. Let's talk next about a polynomial, and then we'll come to a constant multiplier. But so there's that. Let's talk about a polynomial. All right, so we're going to talk about polynomials. Now, keep in mind, we're just going to look at the basic, here we go, the basic x to the n power. Okay, and if we add things together or subtract them, and all this nice stuff is going to work. All right, so let's look at a polynomial. Now, the definition is that we're going to plug this into f of x plus h. So I'm just going to write that in. This is the derivative, so let me say that here. The derivative equals this, minus x to the n all over h. Now, we don't know what this is, but I'm going to work at least out the first two, and it always is this. So the limit as h approaches 0. Well, x plus h to the n power has to be x to the n power plus, the next one has to be h n x to the n minus 1. And then I didn't quite do that right, but yeah, that's okay. Plus, then everything else is going to have multiple h's in it. And then minus x to the n, this is this right here. Okay, we don't know exactly what's inside here, but we do know that all of those are going to have multiple h's. So we're going to divide out by h again. And so this and this will subtract away. And then I'm going to write this in. This all has multiple h's. And so when we divide now, when we divide, what we get is we get, let's divide by h. So what we get is we get n x to the n minus 1 plus, they all have h in them. Now, what is the significance of that? Well, that means that these all go to 0. And so what's left is this right here. So with all confidence, not even knowing what's in that ellipsis there, we can say that the derivative of x to the n power is n x to the n minus 1. All right, well, that's great, because now we can know how to take any derivative of a polynomial. So let's look at an example. So let's take these derivatives. F prime of x equals, this 4 will come in front, that's the n, and then we're going to subtract 1. So this becomes 4x to the third. We can also do this with fractions. So f prime of x, so 1/2 goes in front, and we subtract 1. equals 1/2, and then x to the negative 1/2. Or f prime of x equals -5, x to the -6. All right, so that's simple things. All right, so what happens if we multiply by a constant? Okay, so what happens if our f of x is instead 3x to the 4th? Well, the same thing happens. We're going to multiply the 4 here, and we're going to subtract 1. So this derivative is 12, which is 3 times 4, x to the 3rd power. So all of that stuff remains nice. If I added, if I subtracted, we're going to get all that. So let's look at an example. One more example here. Let's say that f of x equals 2x to the 5th minus 3x to the 3rd plus 2x minus 9. I'll give you a little bit of time now to calculate and figure out what that derivative is. So pause the video, work this out, and when you come back, I'll show you the answer. All right, now that you've worked it out, here's the derivative. 2x to the 5th goes to 10x to the 4th minus 3x cubed. The derivative is minus 9x squared. The derivative of 2x is plus 2. And notice the derivative of 9, because 9 is a constant, its derivative is 0. All right, let's look at the derivative of f of x equals sine of x. Okay, and so we know the only way to calculate this right now is through the definition of the derivative. You do not have to remember this, you just have to know the final results. So we're going to take the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Now you guys remember from pre-calculus that this right here is equal to, so notice sine of x plus h is equal to this right here, and that's what we learned in pre-calculus. Maybe the most important thing we learned in pre-calculus, at least right now it is. All right, and now notice, please, that sine of x and this right here are in common, so we're going to factor that out. And so what we get is so notice when we factor out the sine of x, this is what we get, all right? And I'm going to do something that's, well, no, I'm not going to do that. We'll just, we'll make this happen. All right, so notice I have this plus this all over h. And so what I can do, oh wow, what I can do is I can split that fraction up. And so when we split that fraction up, this is what happens. So we've now split them up into two fractions. And so what we know and what we've learned this year already is that this limit, when h goes to 0, that goes to 0. And this right here, what we've learned this year, when h goes to 0, that goes to 1. So we have 0 times sine of x plus 1 times cosine of x. So this is just equal to cosine of x. All right? So following all of that through, what we have is that if the function is the sine of x, f prime of x equals the cosine of x. All right. Hey, guys, I've taken up enough of your time here.